6.3 goes over exponential functions. This just means that your x value is a power within the expression. So with these exponential functions, you have a constant change that's happening, but unlike your linear equations or your linear functions, that constant rate of change that's happening is by multiplication. So you're used to seeing these linear functions to where you have a constant change of x as well as a constant change of y by addition. With these exponential functions, that change in your y values will happen because of multiplication, not addition. So if you look at example 1, we're just asked if the table represents a linear or an exponential function. If the change in our y values differs by addition, it's a linear function. If it differs because of multiplication, then it's an exponential function. So if we look at example A, we have our x values that are 0, 1, 2, 3. This is just going up by 1. So you add 1 to all of these. We have the constant right there. Forget about it now. Look at your y values. You go from 2 to 4 to 6 to 8. Well, from 2 to 4, we add 2. From 4 to 6, we add 2. From 6 to 8, we add 2. So because there's addition happening here with those y values to get that change, this is a linear function. For example B, we have x values of 0, 1, 2, 3. So those are all going up by 1 by addition. We're good there. We can forget about those. Don't worry about your x values. Look at your y values. You're going from 4 to 8, from 8 to 16, from 16 to 32. 4 plus 4 is 8. However, 8 plus 4 is not 16. So think about it a little differently. 4 times what is 8? Well, if we multiply by 2, we get 8. If we take the 8 and we multiply that by 2, we get 16. 16 times 2 is 32. So because this change in your y values is happening by multiplication, we have an exponential function. For example C, we have our x values of 0, 1, 2, 3. So again, we add 1 to each of these to get the next. For our y values, we have 8, 4, 2, and 1. 8 minus 4 is 4. 4 minus 4 is not 2. Try multiplying it by something. 8 times what is 4? Well, if we divide it by 2, it's the same exact thing as multiplying it by 1/2. So 8 times 1/2 is 4. The 4 times what is 2? 1/2. And the 2 times what is 1? 1/2. So because we're multiplying each of those y values by 1/2 to get our next one, this one is an exponential function as well. For example D, we have x values of -4, 0, 4, and 8. So from -4 to 0, we add 4. From 0 to 4, we add 4. From 4 to 8, we add 4. Our x values all have that consistent rate of change by adding 4, so forget about them. Look at your y values. From 1 to 0, we subtract 1. From 0 to -1, we subtract 1. From -1 to -2, we subtract 1. So because we are adding a -1 to each of these y values, that change is differing by addition. So this is a linear function. For example 2, we're just evaluating these exponential functions, which means we're given a function as y is equal to or f of x is equal to, and we're told what x is equal to. Once we're told what x is equal to, we plug it in and simplify. That's it. So we're looking at example 2a. We're given y is equal to negative 2 times 5 to the power of x, where x is 3. So we're going to plug in that 3 for x and simplify. So it's going to give us y is equal to negative 2 times 5 to the power of 3. That 5 to the power of 3 is 5 times 5 times 5. So 5 times 5 is 25, times 5 again is 125. So that's y is equal to negative 2 times 125. From here, we just multiply. So a negative times a positive is a negative, and 125 times 2 gives us negative 250. For b, we have y is equal to 3 times 0.5 to the power of x, where x is negative 2. When I'm going to rewrite this with that negative 2 and for x, I'm going to turn that 0.5 into a fraction because my x value is a negative, which means I'm going to have to simplify that exponent before I simplify the expression. So if I plug this in, I'm going to have y is equal to 3 times 1/2 to the power of negative 2. If we remember from previous lessons, that negative 2 needs to turn into a positive 2. And by doing that, we can take the reciprocal of the term that is attached to. It's only attached to that 1/2, so turn that 2 into a positive and flip the fraction to make it a positive. So this is going to give us y is equal to 3 times the reciprocal of 1/2 is 2 to the positive second power. Think order of operations when you're simplifying these. You do the 2 to the second power first, so that's y is equal to 3 times 4, which gives you y is equal to 12. For example C, we have y is equal to 2 times 9 to the power of x, where x is negative 2. So again, I'm going to plug this negative 2 in. This is going to give us y is equal to 2 times 9 to the power of negative 2. I want that negative 2 to become a positive 2. So take the reciprocal of 9, flip it. You have y is equal to 2 times 1/9 to the second power. That 1/9 to the second power is 1/9 times 1/9. So that's 1/81. So y is equal to 2 times 1/81. 2 times 1/81 is just 2/81. So y is equal to 2/81. For D, we have y is equal to 2 times 0.9 to the power of x, where x is 0. Now with this one, I'm not going to worry about turning that decimal into a fraction because my power on it is 0. And anything raised to the power of 0 is automatically 1. So this y is equal to 2 times 0.9 to the power of 0. This all becomes a 1, so we're just doing y is equal to 2 times 1, which is just y is equal to 2. For example E, we have y is equal to 2 times 9 to the power of x, and x is 1/2. So this is going to give us y is equal to 2 times 9 to the power of 1/2. Remember, when we're dealing with a power that's a fraction, the numerator is the power, the 2 is your index. So this is y is equal to 2 times the square root of 9 raised to the first power. The square root of 9 is just 3. So we're doing 2 times 3, which is y is equal to 6. For example F, we have y is equal to 1.5 times 2 to the power of x. So this, again, I'm going to just rewrite it to where I plug in that negative 2 for x. So y is equal to 1.5 times 2 to the power of negative 2. I don't want that negative 2. I want a positive 2. So I'm going to take the reciprocal of 2. This is going to give me 1.5 times 1/2 to the power of 2. that 1/2 to the power of 2 is 1/4. So that's y is equal to 1.5 times 1/4. Now I have a decimal times a fraction, and I don't want to work with either or, I want to work with just one. The easiest thing to do is to turn that 1.5 into a fraction. 1.5 is the same exact thing as 1 1/2, which if you turn that into a improper fraction, that 1 times 2 is 1 plus 1, or sorry, 1 times 2 is 2 plus 1 is 3 over 2. So we're doing the same exact thing as y is equal to 3 over 2 times 1 over 4. The 3 times 1 is 3. The 2 times 4 is 8. So y is equal to 3/8. For example, G, we have 1.5 times 2 to the power of x, where x is 0. So again, we're just going to have y is equal to 1.5 times 2 to the power of 0. Anything raised to the power of 0 is 1. So that's just y is equal to 1.5 times 1, which is y is equal to 1.5. For example, H, we have y is equal to 1.5 times 2 to the power of x. This x is 1/2, so that's giving us y is equal to 1.5 times 2 to the power of 1/2. Remember, the power of 1/2 is the square root, so this is just y is equal to 1.5 times the square root of 2. Anything times that root of 2 is itself times that root of 2. So you can just rewrite this as 1.5 square root 2 without those parentheses in between. So our next part of this lesson is graphing exponential functions. When you graph exponential functions, these two tables that you see at the bottom of this page are exactly what your graphs will look like. Okay, they could open different ways, as you see when you're a. You have something that's a times b to the power of x. The number in front of the number that you're raising to the power tells you which way these are opening. Okay, so if we look at some examples, I'll give you a function table with the actual function rule. With the x values, you're just plugging in those x values and solving for y, giving those ordered pairs and plotting them, drawing the line through them. So for example, 3a, you have f of x is equal to 4 times 2 to the power of x. I'm giving you these x values of -2, -1, 0, 1, and 2. So I'm just going to plug them in. I'm going to do 4 times 2 to the power of -2, 4 times 2 to the power of -1, 4 times 2 to the power of 0, 4 times 2 to the power of 1, and 4 times 2 to the second power. So that 4 times 2 to the power of -2 is the same thing as 4 times 1/4, which is 1. The 4 times 2 to the power of -1 is the same as 4 times 1/2, which is 2. The 4 times 2 to the power of 0 is 4 times 1, so that's 4. 4 times 2 to the power of 1 is 4 times 2, which is 8. And 4 times 2 to the second power is 4 times 4, which is 16. So these are giving us ordered pairs of -2, 1, -1, 2, 0, 4, 1, 8, and 2, 16. So if I graph these, that -2, 1 is here, the -1, 2 is here, 0, 4, 1, 8, and 2, 16 is going to be all the way up here somewhere. So with these, I'm going to just draw the line the best I can through these points. You'll see that when I draw this line does not cross over that x-axis. These functions have something called an asymptote. An asymptote is literally a value where the line does not cross over on a coordinate plane. A lot of times they're where x is. So your asymptote here would be x is equal to 0, which just means, y, that's where your y is equal to 0, or y is greater than 0, tells you that that line will never cross past that y-axis or that 0 point on that y. So it won't cross won't go across the x-axis, I'm sorry. Okay, so you'll see that when I draw this line, it's never going to go, it's going to get really, really close to that x-axis, but it's never going to go past or below that x-axis because your y values have to be greater than 0. So when it asks you for your domain and range for these, for this one, you got to look at your line. Look at where your x values are being covered. Your x values are going all the way from negative infinity to positive infinity. Because even though that line will never cross the x-axis and go below it, your line will continue to go to the left until negative infinity. And as it goes up, it continues to go to positive infinity to the right. So your domain, which are your x values, is just all real numbers. Your range are the y values that are being covered. So this is where your asymptote plays a factor in. We said that in this case, that line will not cross past that x-axis, so we'll never go below it, which means your y values have to be greater than that x-axis. Where is that x-axis on your y-axis? At 0. So y has to be greater than 0. If we look at example B, we have f of x is equal to negative 2 times 4 to the power of x. I'm giving you x values of negative 2, negative 1, 0, 1, and 2. So we're just plugging these in. So it's going to be negative 2 times 4 to the power of negative 2. Negative 2 times 4 to the power of negative 1, Negative 2 times 4 to the power of 0. Negative 2 times 4 to the first power. And negative 2 times 4 to the second power. So that 4 to the negative second power is 1 over 4 squared. So that's negative 2 times 1 over 16. That gives us negative 2 over 16, which is 1 over 8, negative 1 over 8. For your next one, that negative 2 times 4 to the negative first power, that negative first power gives that 4 as 1 over 4. So that's just negative 2 times 1/4. That's going to give us negative 2 over 4, which is negative 1/2. The negative 2 times 4 to the power of 0 is negative 2 times 1. That's negative 2. Negative 2 times 4 to the first power is negative 2 times 4, which is negative 8. Negative 2 times 4 squared is negative 2 times 16, which is negative 32. So these are giving us ordered pairs of negative 2, negative 1/8, negative 1, negative 1/2, 0, negative 2, 1, negative 8, and 2, negative 32. So plotting these on your coordinate plane, starting with that negative 2, negative 1/8. I'm going to go to the left 2, down 1/8. And again, it's going to be really, really close to that x-axis, but it's not going to be on it or cross it. Then I have negative 1, negative 1/2. So right in the middle there. Then 0, negative 2, 1, negative 8. And that 2, negative 32, I'm not going to fit on this coordinate plane, so I'm just going to draw my line as best I can. So from here, I'm going to look at that line and give my domain and range. My domain, you'll see that this goes to the left with an arrow, so it's to a negative infinity. And then as it goes down, it continues to go to the right, so that's positive infinity. So it's all real numbers. Your range, that line is not crossing above the x-axis, so your y values are less than 0. For example 4, we have f of x is equal to a negative 1/2 to the power of x. I'm giving you x values of negative 2, negative 1, 0, 1, and 2. So again, I'm just going to plug these in. So this is going to give us negative times 1/2 to the negative 2, a negative times 1/2 to the negative 1, a negative 1/2 to the power of 0, a negative times 1/2 to the power of 1, and a negative times 1/2 to the power of 2. So that 1/2 to the negative second power is just 2 squared. So that's 4. That's an opposite of 4. That's going to give us negative 4. For negative 1, we have that negative 1/2 to the negative first power, which is 2. So that's the opposite of 2, which is negative 2. For the power of 0, it's just the opposite of 1. So that's negative 1. For the first power, it's the opposite of 1/2. So that's negative 1/2. And the opposite of the 1/2 to the second power is the opposite of 1/4. So that's negative 1/4. So we have negative 2, negative 4, negative 1, negative 2, 0, negative 1, 1, negative 1/2, and 2, negative 1/4. Oops. So to plot these, I'm going to find that negative 2, negative 4. So I'm going to go to the left 2, down 4. Plot my first point. Then I have negative 1, negative 2. I have 0, negative 1. 1, negative 1/2. And 2, negative 1/4. So if you see here, this line is going to continue to go out as it goes to the left. And then it's going to continue to go to the right, but never cross over that x-axis. So for your domain here, you have all real numbers because it goes to the left as it goes down and it goes to the right consistently. Your range, it's not crossing above that x-axis, so y is less than 0. For our next example, we have f of x is equal to 2 times 1/4 to the power of x. I'm going to get rid of this. We're not going to look at this. And we're going to plug these values in of negative 2, negative 1, 0, 1, and 2. So we're going to have 2 times 1/4 to the power of negative 2, 2 times 1/4 to the power of negative 1, 2 times 1/4 to the power of 0, and 2 times 1/4 to the first power, as well as 2 times 1/4 to the second power. So this is giving us 2 times 4 to the power of 2, which is 16. 2 times 4 to the power of 1, which is 4. 2 times 1, 2 times 1/4, and 2 times 1/16. So 2 times 16 is 32. 2 times 4 is 8. 2 times 1 is 2. 2 times 1/4 is 2 over 4, which is 1/2. And 2 times 1/16 is 2 over 16, which is 1/8. So we have ordered pairs of negative 2, 32, negative 1, 8, 0, 2, 1, 1/2, and 2, 1/8. So to plot these, that negative 2, 32, I'm not going to plot because it's not going to fit on my coordinate plane. That negative 1, 8 is here. Then I have 0, 2, 1, 1/2, which is here, and 2, 1/8, which is about here. So it's going to get really, really close to that x-axis and curve to go back up, going to the left. So with this, it's giving us a domain of automatically all real numbers and a range of y is greater than 0.